Cosmic forensics. 4.5 billion years ago, young Earth wasn't alone on its orbit. We all know the classic story, the catastrophe known as the giant impact. A Mars-sized planetary embryo, the object we now call Theia, slammed into our planet. This cataclysm melted Earth's crust, blasted billions of tons of debris into space, and eventually gave birth to our silent companion, the Moon. This is the canonical model of the Earth-Moon system. But for decades, one huge gap remained, the problem scientists called the isotopic crisis. If Theia came from elsewhere in the solar system, say from Mars's orbit or the asteroid belt, it should have carried a different chemical fingerprint, a different genetic code. Yet the soil samples returned by the Apollo missions revealed something nearly impossible. The isotopic composition of oxygen, titanium, and other elements on the Moon and Earth was almost identical. How could two different planets, formed under different conditions, be so alike? For years, this paradox was one of the biggest mysteries in planetary science. New evidence. Today, thanks to a new study published in Science, we finally seem to have an answer, and it forces us to redraw the map of the early solar system. Theia wasn't an outsider from the cold outskirts. She was our hot sibling, born even closer to the Sun than Earth itself. To understand this discovery, we need to dive into geochemistry. Researchers analyzed nucleosynthetic isotopic anomalies, focusing specifically on isotopes of ruthenium, molybdenum, and titanium. Here's the key. During its formation, the early solar system was sharply divided into two regions, the inner, non-carbonaceous zone of high temperatures and the outer, carbonaceous zone rich in volatiles and water. The new data shows that both Earth and the Moon formed exclusively from material of the inner reservoir. There is no evidence that carbon-rich, water-bearing meteorites from the outer region significantly contributed to Theia's composition. This disproves earlier theories that Earth's water was delivered by Theia. Where exactly was Theia born? Here's where things get really interesting. By comparing titanium-50 isotopes in samples of lunar mantle and Earth rocks, scientists found a striking correlation pointing to Theia's birthplace. Its composition most closely matches enstatite chondrites, a type of meteorite formed under extremely oxygen-poor, high-temperature conditions. This material is characteristic of the orbits of Mercury and Venus. This means Theia formed closer to the Sun, in a region where the protoplanetary disk was scorching hot and dry. She likely migrated outward under gravitational disturbances from Jupiter or other growing protoplanets, until her trajectory fatally intersected with that of proto-Earth. Why this matters? Why is this discovery so important? Because it solves the long-standing similarity puzzle between Earth and the Moon. If Earth and Theia were built from the same construction material in the inner disk, their isotopic match becomes natural, not anomalous. The small differences that do exist can be explained by Theia forming in slightly hotter, more extreme conditions closer to the Sun. This also reshapes our understanding of Earth's volatiles. If Theia was dry and forged near the Sun, she couldn't have delivered our water. That means water and organic compounds arrived later, during the late heavy bombardment, or were already present in Earth's early building blocks in other forms. Imagine the chaos of that era. The inner solar system was crowded, several large bodies competing for material and stable orbits. Collision was not an accident. It was evolutionary selection among planets. We often think of the Moon as a separate celestial body, but this data shows the Moon is part Theia, part early Earth. We are a chimera, a a fusion of two worlds born side by side. Theia died, but her material became part of our planet, and her core likely merged with Earth's, altering our geodynamics forever. And there's more. Had Theia formed farther from the Sun, she would have been richer in iron oxides and water. A collision with such a body would have created a completely different atmosphere, possibly one that never allowed life to emerge. The fact that she was hot, dry, and forged close to the Sun may have been one of the key factors that stabilized Earth after the impact. In the end, the new science study settles many long-standing debates. The Moon is not an adopted child, and not the product of a collision with a stranger. It is flesh of the same inner solar system. Theia died, but her material became part of our planet, and her core likely merged with Earth's, altering our geodynamics forever. Every time we look at the night sky, we're not just seeing a satellite. We're seeing the remains of a world that could have become another Venus or Mercury, but instead became part of our story. Once again, science reminds us to create something as stable and beautiful as the Earth-Moon system, the universe had to go through destruction on a planetary scale.